Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
And, Kirk, we were chatting for a bit, and I think we ended up with listing like 15 different topics for today. It was like we never seem to lack anything. But one that came up that I said, we got to talk about that is that, reliability engineers often are in a spot where they influence the design, saying, well, this isn't going to work or this will work. Or,
right.
One of the hurdles is you have to stop being the bearer of bad news all the time. You got to actually say, well, this part will work.
Right.
And that every product design or every factory, startup in selecting equipment and stuff has got a few trade-offs.
That's engineering.
Yeah. And we could buy more expensive stuff, or we could design more, robustness into it. And we could do all this stuff. But at some point, somebody along the line says, would you stop fussing with this? Let's make some money. Let's sell this, or let's turn it on.
Right.
Right. And I've read a book years and years ago that influenced me greatly. It was Quality is Free by Phil Crosby.
Mm-hmm.
And he made the argument that the cost of improving quality, it was the thesis of this book, and by extension, I believe also with reliability, continues to pay out way more than you get a better ROI on it, even if you keep improving it. And yet the idea is that at some point, somebody's going to say, well, you can't improve it forever because we actually have to ship it. We got to turn it on and start using it. So
you run out of time. Right. Yeah.
And we set time limits and all kinds of stuff like that. But the issue is that how do you deal with that attitude of we don't have hardly any evidence one way or the other. We've got a handful of tests we've run. Made some prototypes and built them, and some worked, some didn't.
Right.
And we made some improvements. And we're good enough. Versus other teams, I'm sure you've worked with a couple of teams that do a really good job. They track down and nail down all their field failure type stuff. They find stuff in their prototypes and they sort those out and nail it down. And they make improvements just because they can, for as long as they can.
Right. And the bottom, I guess the understanding is that for me, that standard materials in electronics and capabilities are pretty extreme, are pretty robust, really.
In most cases, unless you put them under the hood of your car, then they're
under you put it. But even there, you
use gallium arsenic, gallium chips, and you use very high temperature and robust circuit boards. It's not your computer stuff.
Well, that's true, and just like oil well monitoring, drilling equipment.
What a different world that is.
It's a whole different world, right? And I'm talking about also, the space, our spacecraft, stuff. and the robots on Mars. They're all, some of it is standard old technology. They didn't invent, and they may use some special materials, but for the most part, it's pretty robust. And this is a common question in the HALT, highly accelerated limit testing. Use that term.
You're changing the term.
It really. Yeah,
Greg wouldn't appreciate that.
No, I know, but he's long gone. And it really doesn't make sense to say life testing anymore, I think. But in this, it's like, where do I stop? I keep breaking it and then trying to make it stronger there and,
Well, Greg, speaking for Greg in this case, and usually you invoke Greg's stuff, is that you keep fixing things you find until you get to the technological limit.
Right, of standard materials, and you don't start using special metals, titanium or anything like that.
Right. If you got a polymer case on your product, and you're 50 degrees Celsius away from your softening point or melt point, and that's your first failure, you're good. Ship it.
Right. And you develop these over time, and experienced people know kind of what the capabilities of these materials are. And you should, part of your understanding of electronics and electronics materials is understanding the limitations, like, reflow temperatures of solder and the melting point of plastics. Those kind of things are real common.
They
And
are,
those
but
are limitations that are intrinsic to the materials.
well,
So
one that surprises me over and over and over again is people look at a ceramic capacitor and say, "Well, it's standard stuff. It's used everywhere. It must be good." And
right,
then they put it on a board that they bend into position. They flex the board to get it into the
right,
device, and I'm like,
right,
all right. And you can hear all these parts cracking
right,
and vias
right.
cracking and leads crack. And I'm like, just because it's on every product doesn't mean you can bend it.
Right.
It's like,
It's
stop
not
it.
those products, they didn't bend them, especially MLCCs.
Oh
That's,
man, it's a
we've
piece of
always talked
glass.
about that. It's just constant.
Yeah.
And that can be found just in the mounting of how the board is mounted.
Mounted, or it's hand soldered. What a disaster for MLCs,
Yeah.
multi-layer ceramic capacitors. You're
Yes.
guaranteed to crack it with a 450-degree tip on your soldering iron, and then like
That's why you put 1,000 on your board, because
some of them will work, and you hope there are
some
enough
will
of
work, and
them.
you hope they work in the critical spots. Like, I said, why did they put so many I asked one designer. He said, well, it's kind of just err on the side of caution, and there might be a transient coming off this line or something, and
Yep.
we put it on there.
Well, I had one guy, he told me, he says, well, it's, what's next in the design? And he goes, well, I got to get out my capacitor salt, shaker and just kind of sprinkle them all over the board. And what do you do that for? He says,
Yeah,
when we do cost reduction next cycle, then I have something to take off the board.
yeah.
Like,
And they're
what?
almost as small as a salt crystal these
Oh, they are.
days.
Yeah. And he was
So,
like, okay. He says, I don't
yeah,
have time to figure out where I really need them. So I put them everywhere. And then
all right,
next cycle, when we have time, I'll figure out which ones we really need. And
all
okay,
right.
makes sense.
But you don't even know capacitors are very difficult to detect when they're open.
Or when they're not there.
When they're not there, because they're open most of the time.
Well,
This is
you know it when you fail there's the regulatory test for
yeah,
emitted radiation and stuff, and a lot
right,
of capacitors are used to damp that stuff down. Not all
right,
of them. There's other real purposes for capacitors, but they're kind of a security blanket of keeping stray signals from getting there where you don't want it. But anyway, we put in a bunch of parts on there.
right.
I've heard the argument that and I've run into this more in the mechanical world than in even electronics. I believe it's true, is that an elegant design that simply solves the problem is
Yes,
generally more reliable.
right,
I'm
right.
I'm sitting at a wooden desk, my office desk, right?
Uh-huh.
And I've had it for 40 years.
Yes.
I dust it once in a while. That's about it.
Yeah.
And desks have been created out of wood since I don't know when, long, long,
Yeah.
long, long time ago.
You're right.
Right?
Centuries.
Millennia, kind of thing.
Right.
And yet people are constantly inventing new desks that have swoops and swirls and glass and all the other stuff on it. And then somebody drops a coffee cup on it and breaks the glass. And like, okay, what? Why do I need that? But anyway,
Right.
I digress.
But basic functionality is certainly you know better in some cases than the fancy uh, you know decorated one. So anyway, yeah, I agree that some of our products, they don't really need revision and improvement like the iPhone. Like they do with the iPhone. The
Yeah.
desk that I've brought from Texas and had for 20 years, 25 years. And you see a lot of antique desks that are
Mm-hmm.
still very usable, functional, and
And
work
beautiful
great
too.
and beautiful too. So yeah, I say that. But getting back to testing and you know, I think the fundamental question is, where do we quit improving the product
Mm-hmm.
before we ship it? And I think that uh, that's of course where quick step stress limit testing will kind of determine, that you can what you've benchmarked in your own mind what previous, and usually there's always a previous design or a predecessor design that you've had issues with in the field. And I've dealt with clients that are doing an iteration. They really don't know what caused the failures in their previous design.
Well, I think there's two sources, and because I fully believe, and this may run afoul of your philosophy here, Kirk, is that if you've got a previous product and you've paid attention to things that are failing there and did due diligence on it, right? Did the failure analysis.
Right.
Didn't, oh, that was just a customer complaint. Oh, we don't have time to do that. We're going to redesign the new one anyway.
Right.
And then you tell the designer, you got to fix these 4 things that failed. Well, how are they failing? Well, we don't know, but it doesn't turn on sometimes. So you got to fix that.
Right.
Like, what do I fix? So field data, field information, field failures, and customer complaints is gold if you take care of that and deal with it. And I think we should probably talk about that at a different place. And then you go to testing, right? Whether it's HALT or some other style of testing, and then you find things, you learn stuff from your prototypes. That's the second source. And then you get a team that pays attention to both of those things and has reasonably good data on it. The trade-off point is like for HALT, at some point we have to go to titanium before, in the super exotic component to make this work. And then what we have now will work in a use environment.
Right.
The other piece of this I run into is that about, I don't know, a third of projects I've ever been associated with get delayed for one reason or another. And sometimes it's because their test strategy, their product development strategy is, I had one program manager tell me this, is we plan for success. All right.
Yeah.
That's great.
And I hope so.
Well, they plan for success, but they do it with no backup. So they run, the only time I got prototypes to go evaluate for these high risk areas of it and then find out it really doesn't work. And then 60% are going to fail. All of a sudden that trade-off discussion becomes real simple because I show them, and this is a real story, is I showed a HALT where there was smoke coming out of this handheld product.
Yeah.
And that's not good. And they said, and so we pulled it apart and found what the root cause was, and they were able to fix it pretty quick in the production of this. It was a production added little foam piece of tape to insulate it. Where the short was occurring, and they redid one of the leads and stuff like that. But it was pretty darn quick.
Right.
But more times than not, is you come into a program and you get your final results for these critical pieces of information that say, no, it's not ready. And then all of a sudden they have an extra month they can work on it. And it costs them millions and millions of dollars some cases, but they're saying, well, we can't have a 10% field failure rate. Right. So if you do due diligence and do the good homework and understand the business proposition or how much it costs if it fails and all those kinds of things, you can participate in that trade-off discussion. But walking into the door and saying, hey, this didn't work in the HALT, and you have no information about how likely is that to occur in real life, how far from the margin is it, what's the source of the failure, what's the nature of it, what can we do about it?
Right.
Then you're just going to get ignored. We're going to ship it anyway. We'll see what happens.
Right. Well, yeah. Definitely, you can't just say, well, I took it up to this limit and broke. You've got to understand, well, you certainly have to do more than one. And if you say, I took 3 of them up to this
50C and they all failed, then yeah, you got a problem.
Right. Or I took 3 of them up to 90C and this one failed at 50C. I've got something to look at, and this is the cause of it. You've got to link the physics of what may have caused that to the field, to customer situations. You've got to talk about and know how the product is going to be,
how it's going to be used, and stresses
and abused, and there are going to
be
be customers abusing it, and you can't protect against that. It's just like my brother, I was talking about, he's worried about lightning hitting his boat. And I'm sorry, if lightning hits your boat, be thankful that you're not holding on to the mast at the time. And second, yeah, that's what insurance is for, to replace all your electronics, because they are definitely going to fry.
Yep.
There is no electronics that can withstand a lightning strike. Sorry. That's just, yeah, that's
It
just
just does what it does. You can
it's-
ground stuff. You can put lightning rods,
That's right.
which is considered an electrical implement, actually, a lightning rod. It's
Right.
just a big chunk of metal stuck into the ground and then wired to the highest spot in your house.
Right.
And I read it was in Ben Franklin's autobiography or biography. I think it was a biography.
Yes.
Is that, I don't think he invented lightning rods, but he was advocating for him and really helped Philadelphia not burn down over and over again because lightning storms coming through. But he would detect an oncoming lightning storm because he had the lightning rod up and a wire going down through the house and out on the deck on his porch had a little filament there that would flicker and spark and stuff. And it wasn't hitting by lightning, but the air was the clouds were getting charged. So it was going to strike, and they could detect it like a few seconds before it strikes. And he would be playing with that like it was just fun. Like I like that guy.
A few seconds before. Yeah, I asked my brother if he ever saw St. Elmo's fire. I don't know if you know what that is.
Yeah, I know what that is. Yeah.
Okay. And he said, "What's that?" And I said, "Well, if you," because he talked about dodging thunderstorms. I said, "Well, if you're on the top of your mast, this is what sailors saw, and they didn't know about storms, and they certainly shouldn't have been in them. But when the negative ground or whatever the two polarities of this clouds building up a charge, pull up the electrons, they spray off the end of the mast, and it's a beautiful paint brush. And I saw the same phenomena when I was working with linear particle accelerator ion implanters used for doping silicon. We would run them at 200 C, and on the points of the machine, you would see these beautiful little paint brushes, spraying electrons off, and turn out the lights. It was beautiful. I could see where the sailors were charmed right before they got struck.
Yeah.
But, there weren't many electronics on the boat. So, hopefully if they did get struck,
didn't start a fire for him.
Didn't start a fire. It wasn't all that damaging, and probably didn't kill because generally lightning will go on surround the outside of whatever it hits. So anyway, but so you can only build it so robust. I agree. And you kind of also, you have to survey the market and what's out there, what the capabilities of, iPhone being driven to being almost waterproof. I think it is.
But that, a lot of, I think that was Samsung said, hey, I remember one commercial, this guy's walking through and pouring champagne all over it and it's still working. And so shortly after iPhones showed up with water resistant cables and plugs and outlets.
Yeah. And they removed the 3.5 millimeter audio plug because of that.
But it's just part of it is I agree with you, is part of the trade-off is what will work with our market right now.
Right.
And that has a pretty strong financial, insights into, well, if it does this, this, and this, here's our data saying we'll get this much of the market share, and, goes on with that. If we come in and say, and we're going to have a 5% defect rate, and it's going to cost us this much, then it's a true trade-off. Are we going to, make enough money that we can both pay the warranties and not sour the market for our products not being reliable? Is it worth it?
I'd question how you derive the 5%. What is it that you already know about the product that 5% will fail? You can say that, we know 5% of the customers will abuse this and it will come back, broken that way.
I've done that a couple of times with really good data from marketing, is the different different ways customers use it and what percentages and use them in that. And we had a corrosion problem in one product that showed up for people that were along the coast. Your brother would be perfect for the salt fog exposure,
salt fog, right?
And so we had demographic data of where our customers were, and there was a certain, and it wasn't 5%, it was much higher. It was like 20, 30% of customers, because most people live near the coast within 20 miles of it. And we said, well, not everybody lives in salt fog. You got to be really close to the coast or a specific valley or whatever phenomena that goes it. So we made it an educated guess that there was a fraction of those people actually got exposed to salt fog. And we had some, where salt fog phenomena occurs and how often and stuff like that.
Right.
And then we said, all right, instead of the 20 or 30%, if people that buy our products at stores that are within 20 miles of the coast, we said, well, it would be, 1/10 of that to be conservative. And given that and the demographics and the numbers, it was still 5% of our products were likely to be exposed to salt fog sufficiently to cause this corrosion, because we knew the corrosion mechanism, and salt was like
but that's going to take time to it. But it didn't happen immediately. And
no.
I saw that from the big computer company. We saw computers that were in a window on the coast. I mean, the guys and just rust all through the back, and or corrosion. And anybody says, well, you ever seen this? No. And so there's those kind of conditions that I could say. Still, it requires how the customer sets that up. If it's exposed,
the time and used and
you
whatever.
could use it in the basement of a seaside house, and it may not be a big deal. If it goes up to his third-story window where the
windows open half the day.
That's where it's going to be a problem.
Yeah, but that's what we were trying to say, is that understanding the stresses and where your customers have it, and the ways your products are used.
Right. Yeah.
The thing with corrosion is that all you need is the right elements available, and it will happen. And as our products get tighter and tighter and smaller leads and all these other things that we're doing to make really tiny electronics, it doesn't take much to cause a problem. It's, so, and then when it's super packed, like some of our smartphones are, there's not a lot of room for conform or coating or anything else. That's why they don't leave you a battery, pouch that you can open and close like we used to have.
Well, that's a trade-off too for water resistance. You couldn't really do that very well with a completely to make a system completely water sealed. So I can understand that. Just like they took out the 3.5 millimeter audio plug.
That was really only once, Bluetooth and other ways to communicate with your phone got more viable. So it was some of it's technology trade-offs, some of it's customers' expectations or your wants on it. Some of it is just money straight up. But all of those take us doing our homework to have what's the cause, what's its likeliness to happen in the world, how many people would be affected, what's that cost. Those things all matter in part of the discussion. But just saying, oh, it's going to fail through the corrosion is not sufficient. You got to really participate in the business discussion.
Right. And of course, part of that equation is what is it going to cost to make this improvement? And when, do we, but saying that's never going to happen, or denying the customer's ever going to abuse it, things like that is just designers are so conservative
kind of thing. But it's I'm thinking, if you're listening to this, is what excuses have you heard from your design team that 6 months later you had to bite your tongue instead of saying I told you so? Where's that trade-off? What works for you, those kind of things. And then I'd love, maybe for Halloween, when next year in October, we should ask for a bunch of horror stories of I told you so type of kind of scenarios. But if you're listening to this, we'd love to hear from you. What's your take on this and this dealing with trade-offs? And we all have to deal with this at one point or another. And how do you approach it? And, hopefully we gave you a couple ideas or stories about it. But let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us. You can also, Kirk and I and the other hosts of the show are available through LinkedIn and our About pages. So there's plenty of ways for you to get in touch with us. No trade-off there. You can find us.
No trade-offs. Lots of options.
There you go.
So, yeah, thanks for listening, and send us your questions. We'd love to bat them around here.
Yeah, definitely. Thanks, Kirk.
Thanks, Fred. We'll talk to you soon.
Take care now. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.